Okay, so hello and welcome. Here we are, another problem. This is going to be number 1190, reverse substrings between each pair of parentheses. Forgive me, I sometimes just kind of think I might be like a little overwhelmed. Let me check the audio. Is it working? Forgive me, I sometimes... Yeah, I just, there's a lot for me to think about. Sometimes it's difficult to kind of keep it all together. It's just a lot. It's just a lot. Don't know what to say. I don't know, man. I don't know. Anyway, let's just keep going. The plan is to try to get through the last, 53 questions until I hit 1,000. Then I could say I did 1,000 questions and I can, go do something else. Quite frankly, I wanted to get through the whole problem set, but like I said, I'm kind of a little overwhelmed with just other more personal things. And I'm like, yeah, I should probably like take care of those things. They're kicking my butt. It's just a lot to think about. Reverse the strings in each pair of matching parentheses, starting from the innermost one. Your result should not contain any brackets. Oh, okay, interesting. Substring love is reversed first, then the whole string is reversed. Oh, okay. This is an awkward one, huh? All right. I think I know what to do here. So, okay. And by I think I know, I don't actually know what to do here. There are a few things to say about this. This is a good question. This is a good one. So here we have an example at LeetCode where the OC gets reversed to CO, then etdoc gets reversed to codec, then etco, etco, then octet, right? Then ed, it's confusing. No. The whole string gets reversed. So it's etco, then it becomes octet, and then it becomes LE, and that gets reversed. ETCO DE. Yeah, oh, that's confusing. All right, there's only 2,000 characters, so in theory you could do this in quadratic time and basically just do each reversal like in the stack. Just do each reversal one at a time. But I think there's a way to do this in linear time if you're clever. If you're clever about it. That's what I'm gonna try to do. Try to go for the linear time solution. The quadratic time solution is not that easy to program as well. Probably you could just use a stack and then you store you could use a stack of strings, I think. When you see an opening parentheses, you start pushing characters onto the stack. Then you see another under string on the stack, and then you see another opening parentheses, put a new string and start putting new characters. And then when you see closing parentheses, you take the characters that are on the stack, reverse them, and pop them, and add them to the previous string. Yeah, add them to the previous string on the stack. And then you see another closing parentheses, reverse these, pop the string and push it onto what's on top of the stack, then add the next characters, and then pop again, pop in reverse. Yeah. And then at the end, I guess there should be initially just an empty string at the bottom of the stack. And then everything gets pushed on the bottom of that stack. Yeah, that's a pretty reasonable way to do this. Could do it that way. Is that linear time? No. It's not linear time. That works, but it's not linear time. It's quadratic time. The reason it's quadratic is because you could have n over 2 times. You reverse the same characters over and over. That could be, it could be n over 4 times this some section that's got like a whole bunch of reversals, roughly n over 4 reversals, which gives you n squared over 16, which is O of n squared. So yeah, you could imagine there's like a section that just gets reversed over and over again. Yeah, sorry, I'm just thinking about some of the stuff that, I guess it's like overwhelming. It's like, it almost makes me tear up sometimes. I think about some of these things. It's like it's very like, the world is an extremely brutal place, extremely rough and brutal place. Life is very brutal, very brutal. Anyway, so deep breath. I could do it that way. Probably it'll be fast enough. I'm sure it'll be fast enough for the given constraints. I'm wondering if I should just do that and move on. I think you could do this in linear time, though. I think you can do better than what I described. Yeah, the problem is that when I pop, I end up doing a lot. I could end up doing a lot of reversing over and over again for each of these sections, which is excessive. Like I could probably figure out where the character should go in the final string based off of how deep it is in the stack, if that makes sense. I want to say I could do that. I think that's probably true. Could do an analysis. Say, okay, I've got, these characters at the first level, right? So those would get swapped, their positions reversed. And then these characters at this level, yeah, there's like multiple swaps that occur, I suppose. Yeah. I could toggle the number of times the thing gets reversed and reverse the characters that many times. Can I do that? Yeah, it's confusing. Gee. Oh. Where does this thing end up in the final string, right? Ends up, when it gets reversed, the whole section ends up over here, right? OCTE, where the OC, it's a double reverse, OCTE. And then this part, well, it's right in the center, so the whole thing just gets reversed in place. But depending on where this is with respect to the other strings, I don't know. Try to think that one through. Oh boy, I'm pretty sure there's a way to do it. I gotta lay down and think about this one for a minute. I suspect there's a way to do this in linear time. I think so. It's just not obvious at all. I don't know how much time I should spend thinking about this though. Stack-based solution is pretty solid. As I suggested, I think that works just fine. It's just, I don't know, should I spend the time to try to figure this out or just go straight for the quadratic time solution and be done with it? I don't know. Excuse me. Let's see. Huh. I forgot what I was even saying. Sorry, like some of these things in my personal life are like very hard to reconcile with. It's like, holy shit. Oh my god. Oh my god, dude. Life is brutal. Life is just absolutely brutal. And some of these things aren't even necessarily directly affect me. It's just they're hard to ignore, I suppose. But anyway, excuse me. I forgot what I was saying. Yeah, I don't know. This is a hard question to do in linear time. Quadratic time I think works fine. Like I said, a stack-based solution should probably be fine. But how can I do this in linear time? Can I do it? Is that too hard? That might just be too more work than it's worth. You know, like I don't know if I really want to just go through all that. I should just. I got 50 other questions I'm trying to do here. There's got to be a way to do this without. There's got to be a way. There's got to be a way to figure out, depending on where the element is in the stack, right? What its stack depth is, and its position in the entire string, based off of those two, you know, where it's found in the string, based off of those two criteria, I should be able to figure out which index that character ends up at in the final string. Is that fair? I think that's correct. I think that's true. There should be an index that it ends up. I could translate that, right? Is that true? When you reverse, okay. Okay, here we go. Yeah, might be right. Okay, might be right. So think of compositions of functions, right? A reversal of the index for a particular string consists of a linear function being applied to that index, right? So you would have something like, I don't know, let's say you have 4 characters and, you know, the 2 characters in the middle are between parentheses, right? So those, let's say it's like A, B, C, D, E, and, you know, or A, B, C, D, and B and C have parentheses around them, right? So you got 0, 1, 2, and 3. So the 1, 2, when you reverse those 2 characters, you swap 2 with 1 and 1 with 2, right? Now the normal function, like the normal linear function that you have with the reversal over an index, like from, I don't know, let's say we have indices like I to J, and you're going to reverse these indices. I think, well, for 0 to n minus 1, it becomes I gets translated to n minus 1 minus I, and vice versa. N minus 1 minus I gets, or I gets translated to n minus 1 minus I. That's the normal. That's like a normal translation. In indices from 0 to n minus 1. I think it's exactly just, if you had, let's say x is an element of I to j inclusive, then translate an element x to some other position, right, that reverse. I guess it would be, well, you could do it this way. You could say, let's say x is equal to I, and I want to translate it to j. So some f of I equals j, and it's some linear translation, I plus alpha equals j, which means that alpha is exactly j minus I. Is that right? Where I is the left bound. So, excuse me, alpha, what did I say? I said I plus alpha equals j. It's going to be j is going to be, alpha is going to be j minus I, which means x plus alpha is the translation, where alpha is j minus I. So x plus j minus I is how you would reverse. That's the composition of function. That's the composition. That's the function that you're going to apply. So for A, B, C, D, back to the example where the C starts at 1 and the B starts at 1, the C starts at 2. In those cases, I is 1, J is 2, alpha is 2 minus 1 is 1. Oh, no. Yes. No, did I do this right? Add J and subtract I. I don't think I'm doing that right. I don't know if I'm doing that right. That doesn't sound right. I should make it. How about just like, what about if the range was 1 to n minus 2? How about that? That's a little bit easier for me to think about, because the range from 0 to n minus 1 I know is n minus 1 minus I, to translate if I was the indexing variable. Let's do it that way. I think I'm also getting confused using I and J. I use those as indices typically, but I was trying to avoid using A and B because I'm already using A, B, C, and D. I mean, there's too many letters going on here. It's confusing me. All right. Let's just do it. 0 to n minus 1 to n minus 2. If I reverse those, I want to get some f of x, where x is an element from 1 to n minus 2 inclusive, that would take me from 1 to n minus 2 and from n minus 2 to 1. Actually, even easier than that, let me just do point slope form, right? Those are 2 points, f of 1 to n minus 2 and f of n minus 2 to 1. Those are 2 different points on a line, right? Where f is a linear function, a linear line. That's a linear function. That's perfect. That's a lot easier to think about. That's so much easier to explain. That's so much easier to explain. That's how I can figure out the function. Point slope form, I think, is just y minus y sub 0 is equal to m, which is delta y over delta x times x minus x sub 0. Yeah. I just pick one of the points. That's fine. I should be able, and so I could just add y is the translate f of x is just going to be delta of f over delta x times x minus x sub 0 plus y sub 0, right? That's point slope form. So yeah, I should be able to use the 2 points on the like the indices where they're mapping to define the that linear function. That should be relatively straightforward to do. I could probably do that by hand. Like if the boundary, if the interval is A to B inclusive, then that means f of A equals B, f of B equals A, right? Delta y is going to be B minus A. Delta x is going to be A minus B. So actually, that slope is always going to be negative, just negative 1, always. And then x minus x sub 0, I could pick either a or b, right? I could do, let's do f of a equals b. Well, that means x is a, and b is y sub x sub 0 is a, and y sub 0 is b. I get negative x plus a plus b. Is that right? And I think I get the same thing in both points that I select. That's interesting. Negative x plus a plus b. That's what f of x is. X negative, a plus b minus x. Okay, that's how I do reversal. So that's for each character, right? Now for each index, each character at that particular index, for a particular what do you call that? Forgive me. Forgive me. For a particular subsection, those indices, the translation associated with that character, I'm going to apply exactly that linear transformation. F of x equals a plus b minus x, where a and b are the endpoints of the interval inclusive for those characters. Okay, that's not too bad. That's not too bad. So like 1 and 2, a plus b is 1 plus 2 is 3. So 3 minus 1 puts me at 2, and 3 minus 2 puts me at 1. Perfect. That's not too bad. That's reasonable. That's reasonable. Okay, great. Fine. Fair enough. So now if I have multiple compositions of functions going on, right? That's basically what that means. If I'm deeper into the stack, that means I'm applying those linear transformations multiple times, right? So I could basically just do that to map the elements where they need to go. Once I come across a particular element, I don't know all of the. I don't actually have the completed. I don't necessarily have the completed function yet until I actually pop the stack. Does that make sense? In other words, if I go left to right, I won't know. Even let's say I'm at the bottom, or I guess top of the stack. But let's say I'm at the top of the stack. So in the case of like A, B, C, D, where B and C have parentheses surrounding them, I don't actually know the bounds for B and C until I see the closing parentheses. So I can't apply the function to B and C. And in fact, if A, B, C, and D were all wrapped in another set of parentheses, then I wouldn't know then I would not know the other bounds for the other composition until those parentheses are closed. So I wouldn't know all of the compositions that need to be applied. Well, that's interesting. What I'm concerned about there is, I think I end up doing a quadratic amount of work anyway, because the number of compositions applied to a particular character could be very high. And I don't know if I can apply those compositions efficiently. I might be able to get this down to n log n time if I'm really clever. If I'm really clever, I might be able to get this down to n log n time by applying the compositions in a segment tree. So I could potentially use a segment tree to apply the compositions on a range of elements, and do that in logarithmic time. Wow. Okay. Okay. I think that I could use a segment tree to do this more efficiently. Does that make? Hopefully that makes sense. I think that makes sense. Yes. So each of these parentheses represents another composition function that's being applied to that range. And so it's like a range query, which if I want to do these range queries efficiently, or range update really, I can perform these range updates efficiently by applying by using a segment tree to perform the update across a whole set of numbers for each operation. There you go. I like that solution. That's linear arithmetic. That's relatively efficient. Linear arithmetic is quite good. I think that's good. That's probably as good as it's gonna get for me. That's probably as good as it's gonna get for me. So my final answer is I think I can do this in linear arithmetic time using a segment tree. But I'm not gonna go that far. I'm not gonna bother. All right. Okay, that's pretty good. I like that. I'm satisfied with that. Now, if somebody can come up with a linear time approach, that would be very impressive, I think. Linear arithmetic is probably it's pretty good. Linear arithmetic is usually it's usually comparable to linear time. But yeah, you could do. I'm tempted to actually program the segment tree, because you could put a segment tree in something that's it's something that's an array, rather than in a and it would be quite efficient rather than a what's that called? You put a segment tree in something that's an array maybe I should do it just for the practice. I mean, how much time do I have? 26 minutes in. I don't know how long I'm gonna make this video. I kind of want to try to practice with a segment tree. I think this is a good spot to do it. Get that practice. Could do it, yeah. Linear arithmetic time with a segment tree, and I think the query updates, I suppose I'll have just the original indices and the original string, right, on, with all the parentheses removed. And then I'm just going to perform a translation after I do the segment tree manipulations. Interesting. Let's see. Could use a stack also to figure out what the translations are exactly too. That's the operations the queries that need to happen on the segment tree. I think you have to do a one pass through. Like I'm going to use some memory and do like a few extra passes anyway, so I think it's fine to just use a stack to gather what the queries are. This is a good question. I like this question. This is a solid question. To build this segment tree, I'm wondering, how do I do these updates? How do I process this? I guess so. Each update, I'm going to actually apply the function to. I could compose the function could compose the functions, the linear functions, on a particular. Compose the linear functions on a particular node, and then when I calculate each node, I just run through those compositions, right? And there's only, for each position, there's a logarithmic number of compositions that need to be put together for each index. Something like that. Yeah. I just need to do, I'm sure the compositions of linear functions is not that hard, right? Also, I was looking at the Monty Hall problem earlier. I want to maybe make a video on that. Monty Hall problem is pretty interesting. Monty Hall problem is quite a thing. But yeah, linear composition of functions would be, this is a good question to practice segment trees on, absolutely. Let's say I have, I don't know, like, let's say I have 7 7 nodes. I've got 0, 1, 2, 3 are my indices at the bottom. I've got a node that controls 0 to 1, that range. I have another node that controls 2 to 3, another node that controls 1, 2, 3, and 4. And let's say I have, I probably need more nodes. Let's go all the way up. Let's go another level. Let's go to 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay. That's too many. Just go to 0, 7. Okay. This is 0, 1. This is 2, 3. This is 4, 5. And this is 6, 7. Okay. And then these nodes on top, we have 0, 1, 2, 3. Just I probably don't need to do this much extra drawing, but I just want to let me do it, and then I can kind of reassess whether or not I actually needed to do that. 0, 1, 2, 3, 4, 5, 6, 7, because I'm actually not sure, right? What I want is, let's say I have a function 5, 6, 7, right, or just 5, 7. I can calculate the, as I mentioned, f of x, the linear function there is just going to be 5 plus 7 minus x, which is 12 minus x, or minus negative x plus 12, right? And if I had some other linear function, I mean, I'm going to just see like composition of linear functions, what does it look like? If you had m sub 1 x plus b sub 1, and g, that's f of x, and g of x is m sub 2 of x plus b sub 2, and we had f of g of x, right? That's going to be m sub 2 of f of x plus b sub 2, which is going to be m sub 2 of m sub 1 x plus b sub 1 quantity plus b sub 2. Then gives me m sub 1 times m sub 2 times x plus m sub 2 times b sub 1 plus b sub 2. Okay. I'm just thinking here, like, so m sub 3, we'll say, is going to be m sub 1 times m sub 2, and b sub 3 is going to be m sub 2 times, and then you end up with f of g of x is just, you know, m sub 3x plus b sub 3. Yeah, I guess that's fine. I mean, I guess it's, yeah, algebra, and it's pretty straightforward, actually, the algebra, to calculate the new, so so I could represent these nodes and the composition that's associated with these nodes as a particular m and, you know, m and b, right, slope and y-intercept, and then I just calculate the new slope and y-intercept when I apply some composition, and each interval, right, like to calculate the b value, or, well, the y-intercept, we'll call it, you know, y, I don't know, I don't know what to call that. I don't know. We'll just, because okay, let's do it this way. Let's do m and b, and also, just by the way, this m and b, m is always going to be -1 for all of these functions, and b is going to be if it's a reversal over the over the interval a to alpha to beta inclusive, b is always just going to be alpha plus beta, right? And then so applying that that composition to another node, that's exactly how I'm going to calculate. I'm going to calculate b from, so whatever's already there. So the application, it's going to go, whatever's already there is going to be the inside. right? So we're gonna have like sort of f of 2 of x, f of 2 of f of 1 of x. Where f of 1 of x is the part that's already there. Yeah, I kind of did it in a way that was confusing. Let me just rewrite this. Yes, it's good that I'm writing it out. m1 of x plus b1 of x plus b1, f2 of x is m2 of x plus b2, and then we say f2 of f1 of x is m2 of f1 of x plus b2, which is m2 times m1x plus b1 plus b2, which is then m1 times m2 times x plus m2 times b1 plus b2. Okay. Okay, so if I'm applying f2 of x to f of 1 of x, f1 of x is already saved in the node with those values for m and b, and f2 is going to be applied to f of 1, then what I end up with is m is just the m1 times m2, so just multiply the two slopes, and the new b value is going to be m2 times b1 plus b2. So I'm going to multiply the previous b value, so I should do like m sub I plus 1 is going to be m sub I times m sub I plus 1. I don't know. It doesn't really. Never mind. So the b sub 1 was the b that I had there. I'm going to multiply that by the new slope and then add the new y-intercept to that. That's the application that's going to happen to modify that particular node. The way this is going to work is I'm going to update until basically I'm going to break my interval into pieces until all the pieces are present. So like if I have something like 5, 6, 7, that's most likely going to break down into like a piece that's just 5 to 5, another piece that's 6 to 7, right? It should be a logarithmic number of sections, each section being being a power of 2 in terms of size. And so each of those sections I can apply this composition function on those nodes. And then the application itself is going to constitute what I just described, where I'm going to just multiply the two slopes to get the new m value for that particular node, and then update the y-intercept. And so each node just has to keep track of those two values. And that's how I can keep track of all of the compositions. It's really each composition is going to be kind of, each query is going to take logarithmic time. It's going to update those nodes with a newly composed function. The idea is that I think that works. I think that's fine. I think exactly as I described it is fine, or roughly how I described it is fine. Not exactly, but it's kind of hard to explain. So, and it would be better if I was showing you the algebra that I'm doing here. It would be a lot easier to. It'd be easier if I could show you the algebra that I'm doing here. It'd be easier to kind of understand. But then what I can do is, once I've applied all of my compositions across the nodes in the segment tree, and I think the leaves should all just be m is 1 and b is I want to actually apply it to that particular, like if so some value I I want f of I equals I, b is 0, m is 1 and b is 0. Yeah, that's fine. Okay, that works. M is 1 and B is 0 is everything at the bottom of the leaves. So to actually calculate for a given index after all of this happens, I'm going to calculate f of I. I'm going to take all of the compositions in the path down to I and compute each time that delta, right, that change, apply those compositions one at a time on each level, going straight down, down all the way to the bottom, to the leaf, and then just applying that to I and get f of I equals, I times m plus b, right? It's a little confusing, I realize. Like, I don't know, it shouldn't be that hard, but it's a little bit like, I don't know what to say. I guess it is what it is. Okay. I get this feeling that I could probably do things a little bit differently with these functions. Like, it doesn't have to be this kind of compositions of functions type of thing. I don't know. I'm thinking maybe it doesn't have to be done this way, but like, this is a reasonable way to do it. This will work. It'll work. It'll work. I don't know how reasonable it is, but it'll work. I'm pretty sure. I'm fairly certain. Then I can go back with my original string, and I've got all of these translated indices for the leaves, and then I could just write where those right into those new indices. I think it's actually more like it's more like once I've calculated that composition function, I can go left to right through for each index in my original string, calculate that new index using that composition associated with that index, and then just write the character that I have at that string into that new index into another string. If that makes sense. Hopefully that makes sense. Should work. It's not too complicated, at least in theory. That would be n log n time. Or presumably would be n log n time. Okay. Okay. I could just code that. Sure. Also trying to think how exactly I can put together the segment tree. It's very clear when it's divisible by 2, but I'm not so sure how the tree should be set up if it's not divisible by 2. I think the way I could set it up is just take the interval that I have. The first node represents the whole interval, and I just divide on the left side, divide by 2 using integer division on the size. Left node is going to be that half, right node is going to be the other half. But I want to put this into a tree. Not a tree, an array. I want to flatten this into an array. And I'm wondering if there's something special. I think there's a way to do this that uses a memory condensed segment tree type of a thing in an array, which I don't remember how exactly that works. That's another thing I don't remember. It's good for me to practice here. Oh, hey, how's it going? Chip Jones, yeah. Oops. Somebody turn on the toggle here. Forgive me, I'm not sure how long ago you made that comment. Yeah, you could probably store start and end vertices, iterate backwards, and reverse everything in between the indices. Store start and end indices, iterate backwards, reverse everything in between the indices. Oh, instead of storing the whole string in a stack, that's maybe a better idea. Let's see. Oh yeah, that's a good idea. I like that. And get the whole string, and then I think you still end up with the same problem that I was describing before, though. But that's good. That's solid. That works too. Yeah, you could just get the string, write it somewhere, and then, as you mentioned, just get all of the different reversals that need to happen, and then just get the indices, the start and end indices of each reversal, and just apply each operation to the string directly. That's a fair point. You could do it that way too. That works too. It's maybe a little bit easy. That's probably more efficient than the stack and string approach that I was describing before. I like that approach. It's a good one. Probably would want to use a stack to get the start and end indices, though. I don't know. Yeah, the reversal operations can be applied as a composition of functions where you're translating an index to another position. And then those operations can be applied as in a segment tree to apply the operations in logarithmic time as opposed to linear time, right? Because each operation, there could be roughly a linear number of operations, and then each operation each reversal could take a linear amount of time. So that's what I'm going for here. It's almost the same solution you just described, except optimizing it slightly to use a segment tree to optimize how much time it takes to perform each operation. I don't know if you can do. There might be a faster way to do that too. It may not actually need to use a segment tree. Better way to do it. I don't know. I kind of want to do the segment tree approach though, because it's going to be it's good practice to use a segment tree this way. It's good practice. Definitely can be done. I don't know. I don't know about if the tree is not. I'm wondering if I should just raise the. I mean, I could just make the segment tree a full and complete tree and just have, the leaves be exactly the number of nodes, exactly some power of 2. And just have extra nodes that are unused. Like that could just, it's not memory efficient, but it's simple enough to still implement. Excuse me, yeah, for this purpose, it should be fine to do that. That would still be a linear amount of memory. It's just, it would just be double, at most 2n kind of a thing. Yeah, bounded by 2n. I mean, I guess it's fine. Just round it up to the nearest power anyway and allocate that much memory. Yeah. It works. That's easy to think about. I'm pretty sure there's a way to do this that's like a space efficient segment tree that I want to use an array to represent the segment tree. I don't remember how this works. This is the space efficient one. Segment trees are always like kind of a pain in the neck for me to work with. Oh boy. Okay. Oh, excuse me, 4n is maybe what I need. Right, I forgot the number of leaves is n, which means I only need at most 2n leaves, but the internal vertices will be roughly equivalent to that, which is could be another 2n. Gotcha. Not a power of 2. We can see that behavior in the image. Becomes important later during the implementation. Value that gets stored in the merge operation. Convenient to describe it recursively in the other direction. Construction procedure if called on a leaf vertex does the following: recursively constructs the values of the two child vertices, merge the computed values of these children, start the construction, hence able to compute the entire segment tree. Some queries. Okay, so they just go for the basic. Yeah, I should probably just do the basic implementation. There's a way to do it that's memory efficient. There we go. Yeah. So it only requires 2n minus 1 vertices. Be reduced. Renumber the vertices of the tree in the order of an Euler traversal, pre-order traversal. We write all these vertices next to each other. Let's look at a vertex index v and let him be responsible for the segment LR, and let mid equal L plus R over 2. It is obvious that the left child will have the index v plus 1. The left child is responsible for the segment L mid, i.e. there in total there will be 2 times mid minus L plus 1 minus 1 vertices in the left child subtree. Thus we can compute the index of the right child v. Index will be v plus 2 times mid minus L plus 1. By this numbering we achieve a reduction of the necessary memory to 2n. Yeah, I don't know if it's that important for me to do that, but there's a way. If you consider an Euler Tor, then you can compute the if you consider an Euler Tor, then you can compute, I guess, from the parent, what the left child will be responsible for and what the right child will be responsible for. and then I guess whether or not there is a left child or right child. It's a little confusing because I'm trying to think for an array, where is the left child and right child located? Oh, that's it. No, that's where the right child is. Excuse me. Use this to calculate the right child. Okay. Okay. I'm not gonna use that. That's not bad, but it's also, I think, a little bit confusing. Okay. So 4 times max n. Max n, I think, is they don't say what it is, do they? Oh, no, they don't. They just assume you know what that is. Max n. Looking for something specific here. I mean, you could just use 4n as well. That's fine too. It's not. I'm not gonna use all those nodes anyway. So it's fine. 4n is fine too. Yeah, we'll do it that way. Okay, that's fine. All right, let's try. Let's get all the queries. Let's use a stack to get all the queries. Let's actually use a queue for all the queries. Queue of pairs queries. String. Let's say chars or original positions. Int I0. Okay. If stack. Okay. So if ch is an opening parentheses, right? Then I'm going to push onto the stack. Oh, it's my dog. Hold on a second. Be right back. Hi, bud. No, you can't really see her. Oh. What's up, Bubby? Good. Oh. Oh, she went right to my bed. Hi, bud. Yeah. Getting comfortable in the bed? Okay. What's up, Butch? I'm working on something over here, bud. Okay. Yeah, you can rub your face on the bed. That's fine. Yeah, you can't really see her from this angle. That's okay. That's okay. What's up, puppy? Hi, bud. Hi, bud. All right. So we're gonna push the index where it begins is gonna be I plus 1, and I really could use like a case statement too, actually, which is, well, it's 2 if statements. I think it's fine. If it's the other character, I'm going to write to queries. I'm going to say queries. I'm going to push in place. I wonder if I get it in place. Aha! Let's see. Can I place in the yeah, I can. There we go. Place. And place. Whoops. Okay. I want to in place. It's going to be const int st top. This is not st top. It's going to be equal to st top. I don't know what to call this. It's going to be previous. We'll just say. And this is going to be previous and I minus 1. Okay. Otherwise, I'm going to go ahead now. It's not I minus 1. This gets a little bit tricky here, because it's true I want the index to the right of this character, but this isn't going to be in the final string. So I think I could subtract 1, right? Like if it's, think A, B, C, D, right? The index, if there's parentheses between A, B, and C, D, the index 1 is actually going to correspond to the next character to the right. And to 0, 1, 2, 3, 4, index 4 should actually be 0, 1, 2, should be at 2. Would be subtract 2. Yeah, that's a little bit confusing. I think I just need to count the number of characters that are missing. We'll just say int scene is 0. I think it's to be I minus scene, and in both of these cases, increment scene. I think this one does it before, this one does it. This one does it before, this one does it after. All right, dog's getting bored with me. I gotta write it down. I gotta write it down. This doesn't have to be here. This could be here. So if I have like A, B, C, D, E, and F. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's 9 characters. But A, B, C, D, if I put parentheses between C and D and then B and E, right? Then that means 1, 0, 1, 2, 3, 4, 5. So, oh, that doesn't sound good. Hold on a second. That sounds like fluids. Don't puke in here, bud. Hi, Pooch. You go outside? Oh, boy. Did you vomit? Oh. Gross. I see some kind of fluid. Alright, bud, maybe you should go back downstairs. Hi, puppy. Maybe it's time for you to go back downstairs, bud. Alright, I'm gonna close my door. Ew. I don't I see spit. Looks like saliva. I think we're okay. I think we're okay, but yeah, that was a little concerning. Dogs are like children that never grow up. That's sort of, it's like I would not recommend having a dog ever to anybody. Generally speaking, I'd say have children. Don't have dogs, have children. Okay, you don't need a dog. Anyway, so A, B, C, D, F. Yeah. So, when I come to B, its index is actually 1. But the brackets are going to be from 1 to the 8 is E, which is 4, right? So it's going to be from 1 to 4. And then the next one, which was, so that was 1 to 8, but it should be translated to 1 to 4. And the next one is going to be from 3 to 6, but that should be translated from 2 to 3. Hopefully it makes sense. Hopefully you can see what I'm getting at here. Because I'm removing characters as I see them, so that's not, those should be basically decremented from the index that I'm currently looking at. So when I look at index and I look at 1, I subtract 0, right? Because B is going to be shifted down to 1 from 2, and then I count that parentheses as being covered for the next position. So when I see the next parentheses at 3, I subtract that, I get 2, right? And then I also increment that to 2. Then when I get to 6, I've seen 2. I should decrement that to 4, but also I subtract another 1. I subtract another 1 because the interval itself is actually to the left of this index that I'm interested in, whereas on the other side it was to the right. Like the other side was more like it's a similar thing, but it was more like I plus 1 minus seen, right? I could have done it this way, but it's easier just to put it down here and then subtract 1 from the get-go. And then over here, instead of subtracting 1 now, I could just put this first, right? So could just modify the positioning. So then when I see 6, I add first and then subtract all 3, and I get I complete that 2, 3. And then when I see 8, same thing. There's 4. 8 minus 4 is 4. Yeah, that's correct. That should be right. That should be right. Just have to keep track of the characters that I've seen and I'm removing from the string as I go. So I should be able to do that in also relatively easily in that way. So I push I minus seen onto the stack, and then I pop that from the stack, and push that into the queries, right? And otherwise, I'm just going to take the original position, and I'm going to add this character. Very straightforward. Okay, that gives me all the queries, and then now I want to build a segment tree. So we'll call it segtree. This is going to be an array of integers. It actually should be, I'm going to use a pair of integers. And I kind of explained it before. An array of pairs. And I'm going to say constant n is going to be the original position size. Right, these queries again are going to be with respect to the string that doesn't have the opening and closing parentheses. And this is going to be 4 times n. And I want to fill it with empty pairs. Let's do it this way, m, n. So I don't have to keep writing over and over again. Okay, so empty pairs. Hopefully I can do it this way, construct an empty pair. Now what I want to do, actually no, I don't want to do it that way. I want to do 1, 0. That's even better. That's even better. So everything has a slope of 1 and a y-intercept of 0, right? Those are all the functions. So now I want to really want to apply each query, quite frankly, because I basically already know. I don't think I have to do more setup than that, actually. I think I can just apply each query. So while queries is not empty, it's just queries. Yeah. So while queries are not empty, P is going to be queries front. I could use AB. What am I doing here? Okay, it's been like an hour. Could destructure in this way. There's another way to destructure this too, but I'm going to use this approach. So N, M, or M2 more like, we'll say M2 is just always -1. And then B2 is going to be A plus B, right? And then it's going to be I don't know if I can do this iteratively. I think I do need to do this recursively. Maybe I'm wrong about this. Well, I could use a queue to do it recursively. Yeah. Okay, let's try to do a level order traversal. Another queue. Yeah. Could try this. I prefer to do things iteratively if I can. So push AB. While not queue is empty. We'll just say update. Yeah, we'll come back to these things. Well, actually, that's fine. No, M2 and B2 is fine. Okay. This is a little bit confusing. Oh boy. Update and next update. Can I do it this way? I'm a little confused. I'll come back to that in a minute. Okay. Interesting. So I push AB into the update queue. So for each query, I'm going to do a level order traversal, right? Level order traversal typically has 2 while loops. It starts with an update. And what I'm going to do is take this M2, B2, and the way it's going to work is while my update's not empty, I have a next update, and then I'm going to go through all of the values in the update queue, and then I'm going to push things into the next update queue. Now, things in the update, so this is going to be const auto, we'll say query pair, might be easier. Call this alpha and beta, because I want to use A and B later. Okay. Deep breath. Update front, update pop. This is also going to get pop too. I don't know if I have to pop the front. Yeah. Okay. All right. Update front P, AB, AB equals P, update pop. All right. Sorry. What is it? I'm kind of like meandering my way through this a bit, and also just thinking about things that are like some of these things I mentioned earlier in my personal life are kind of challenging. Some of these things are also like very awkward, very awkward, and a little confusing. And it's like, oh man, like what? Oh boy. So forgive me. I'm thinking about stuff as we're doing things here. As I'm doing this. All right. So the node. How does this work? No, the update is not going to be alpha and beta. It's going to be I and J. Index. It should be an index. Start from 0, and then I try to update recursively 0, 1 and 2. 2 times 0 plus 1, 2 times 0 plus 2. And then excuse me. I don't want to use a tuple. How do I know range this particular node is responsible for. That's confusing. Forgive me, this part is definitely segment tree related stuff that I don't practice very much. Excuse me. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, or no, just 14. 14, okay. Excuse me. Can I derive the size and position from the index? Should I do that? Seems bad. That seems kind of bad. I don't know if that makes sense. Excuse me. Maybe I should use struct. Think about using a tuple. Maybe I should just use a struct. I was watching someone earlier who was showing me that you can use a struct. You can use a struct instead of a call it segment. You can use a struct instead of a tuple, and that's maybe a little bit better. Maybe that's a little bit better than can use a struct instead of a tuple, and maybe that's better than a tuple, which I think is good. I agree. Excuse me. So the queries are still going to be pairs events. That's true. The updates are going to be integers, indices into the segments. I think we're going to do updates in a way that's similar to the this is confusing, yeah. Definitely very confusing. Yeah, I'm a little confused here. These should probably be 0, 0, 1, 0. Okay. Let's push this back. Queries front, query P, alpha, beta, query P, pop queries. Okay, I don't need to do all that. No. Update, or initial, or just initial queue. This could actually be update. Also a little concerned that my dog doesn't go to the bathroom in the house. Smell every now and then, make sure. Excuse me, to initialize, we're going to say segment of 0, A is 0, segment of 0, let's do segment reference X is segment of 0, XA is 0, XB is n-1. It shouldn't be n-1, it should be actually, yeah, no, n-1, that's right, that's fine. M is 1, Y int is, everything should be, oh, these are the other values should be the defaults. What initializes A and B values for each segment? Excuse me. What initializes each segment? Oh boy. Just forgive me checking to see. What if it's empty? I guess I'd want to check too. Also, if it's an empty string, that could be a little bit awkward. If n is 0, I might have to. Just return something of an edge case. Anyway, I'm getting a bit tired here. It's a bunch of things to go through for sure. So let's create this queue. It's not empty. We're gonna have the next update. This is gonna be integers. It's not empty. Int is gonna be index is the front. I'm gonna go ahead and pop the index off, and then say current A start segment tree of XA, current B, segment index B. And now what I want to do is write to the left child and the right child. Two times index plus 1. And 2 times index plus 2. Okay. Oh boy, this is really taking a while, huh? This is Forgive me. Forgive me. It's taking me a while. I don't know. I'm just sort of, like I said, kind of walking, meandering my way through this, I suppose. Left A and left B. The midpoint should be current A plus current B minus current A divided by 2. Okay. And it's going to be current A to mid, and right A is going to be mid plus 1 to right B, which is current B. Okay. And then both of those should get pushed onto the update queue. I'll just do this kind of a thing. Seems like a lot of effort for what I'm doing here. It's definitely a way to do this. It's not so challenging. Or just, I don't know, it seems like a lot of extra work to set this up. I feel like I'm not doing it correctly. I've definitely seen like much more terse implementations of a segment tree. Anyway, so I want to update all of my, each part of the segment tree. I think by default it'll have m as 1 and y is into 0. I could add those parts, but I'm not gonna bother. It's fine. So basically, I get my index, pop it, get my current A, current B, get my left index and right index, which is just multiply by 2 and add 1. And then add another one to get the right index. Then I take my left segment and my right segment, and I get the midpoint between current A and current B. And then I set on the left side and the right side those, basically split the range in half on the left side and the right side, and then push those indices to continue getting updated. Yeah, and I guess all I need to do here is just say if left index is greater than n, less than n, and same thing on the other side. Oops. Right index. And there's a little bit of duplicated code here, but it's not that bad. It's just 2 elements. It's pretty manageable. Yeah, so I think it's reasonable. The query kind of mirrors this. That's the setup, and then the query is very similar. Let's go ahead and push that in. Update push 0. Next update doesn't need to have a pair. Update front. So A and B, current A, current B, update move. This is maybe the thing. I think I already have that though, yeah. All of that is fine. All that's fine. What's going to happen here is I'm going to perform the query now with alpha and beta. And I'm going to say, if there's an intersection then I'm going to split alpha and beta on that intersection with. So yeah, so I get left index and right index. I'm going to say auto segment or just auto seg. Actually, this is fine. No. I should say auto seg. Yeah, we'll do that. I don't know what to name this. Current segment. Let's do current segment. Okay. Oh no, I think. Oh, this is very awkward, huh? I don't think I'm doing this correct. I should have thought this through a little bit more. This is not quite right. I think. I'm wondering if I want to push a whole query segment into my queue rather than the index. Well, the index gives me the whole query segment, but it's. The problem is that I need to know which indices I'm going to process. And then I also have like the query that's being processed on those segments. And I want to modify, like there's a few things that I'm going to do based off of the query and the segment. Oh, it's confusing. I'm like kind of, yeah, it's definitely easier to do recursively, easier to think about recursively. But excuse me. I think I'm getting really tired. Also, I think the food that I ate before is kind of starting to hit me here. So many excuses. So many excuses. I mean, I could use a tuple here. I could use a tuple. It seems awkward, but yeah, maybe the right thing to do. Like, or it's just or just another struct that gives me not just a segment, but a segment query or a segment query section. Just query. I don't know what to call it. Query interval query. It's like a portion of a query. I don't know what to call this. Query portion seems really awkward. Index A and B. And it's not going to be update anymore. It's going to be query portions, a queue of query portions. New update. Now this is going to be something like the following. Index 0. I don't know if this has a default constructor. I could use it this way, but I could try alpha and beta. And now Yeah, a little awkward. It's query portions. Okay. That's what I'm gonna call it, QP. Just gonna go ahead and call it a QP. So the current segment, current A, current B, and there's the left and the right indices that I'm going to operate on. There's the midpoints. What I'm going to want to look at is I want to do there's a couple things I want to do. I don't think I'm doing this the best way I could here. I think there might be a better way of doing this. Friends are going to get food. They invited me, and I told them no, I think I should study, which I think this has been, so far has been kind of a fruitful thing. Good practice. And it's like everybody took the day off today, so it's just everywhere you go is totally flooded with people. And yeah, I told them I didn't want to go because I wanted to study, but I'm like falling asleep though. This is like, I don't know, I'm probably gonna take a nap after this question, assuming I finish this relatively quickly. Assuming I can finish this. So I get the index for the query, get the A and the B values of the query, pop from the query, and then I get my current segment associated with that index. Get the current segments A, current segments B, get the left index and right index. The way this is going to work is if this subsumes, so if A is equal to current A and B is equal to current B, then I stop there, right? And I continue. And what I'm going to do is take this current segment. I think I mentioned I'm going to take the M value and multiply it by M2. Yeah, multiply by M2. And I'm going to take the int y value, which is B, and I'm going to take itself, multiply that by M2, and add B2. Right, so apply this to that segment if they line up. Otherwise, I've got the left index, I've got the right index. I'm going to get the midpoint of these two. Really, it's if there's no intersection at all, then I also continue. Right, that's another element to this. Let me go back, actually. I might need to do that. If there's no intersection at all, which it's it's A, I think, is less than or equal to, if you had A, B, and in two intervals A, B, and C, D, they overlap when A is less than or equal to C. Is that how it goes? A is less than or equal to C, and no, B, I think it's A is less than or equal to D, and B is and C is less than or equal to B. That's confusing. Yeah, I'm trying to remember exactly how that works. A, B, you want to see if they overlap at some point. That means that B is greater than or equal to C, and A is less than or equal to D. Yeah, I think this is fine. I think it works like this. A is less than or equal to D, and C is less than or equal to B. Because even if you swap the two intervals, it's the same thing, right? It was C, D, and A, B. You have A is less than or equal to D, and B is less than or equal to C. Or yeah, then C is less than or equal to D. Yeah, that's correct. Yeah. All right. So there's no intersection. You stop if they're totally in line, and then update is performed there, and there's a stop. And then finally, I got my left index, right index, and I'm going to push the left index, right index, and a modification of the query. That part was why I think I needed to have a query portion here. These are also in place and in place. So what happens is I have my left side is part of the query, and that should be, there's a midpoint of, so where this gets interesting, there's left index and right index. I want to say this should be, yeah, it gets confusing here. Oh no. Oh no. No. I want to say something like the following. Hold on a second. Hold on a minute. I live in a world of a million distractions. Trying to do difficult work that it's hard for me to even focus on in the first place. All right, I'm not entirely sure what this is going to look like. What this is going to be. There's an L1 and R1, and L2 and R2. And the reason why I want these variables here is this has to be the case, but also L1 has to be less than or equal to R1 for this to make sense, and L2 has to be less than or equal to R2 for this to make sense. And you guess this is going to be L2 and R2, same thing, or L1 and R1. This is going to be the same thing here. L2 and R2. Oh, okay. So, what's L1 going to be? The L1 should be. Don't tell me I have to put more if statements in here. No. No. I'm trying to do this. I'm not trying to do that. I'm trying to do this like at this point, not trying to duplicate this here on each of the left and right parts of the query, but it seems like I might have to do this actually as part of the. Oh my goodness, this is so annoying. I thought this was going to be easier if I did it using a level order. If I did it, level order traversal. I thought it'd be easier, but I think I'm wrong. Just wrong. Just wrong, man. Okay. How? What did I do? No. I don't know. I mean, I know, but so okay. The query, it has some kind of overlap, right? The query that I'm trying to perform has some kind of overlap with the particular segment that I'm interested in. Fine. Now what I've got to do is split the query into two pieces based off of the split point of the segment, right? Which actually is fine to do it this way. This is fine. Current A, current B, right? Just get the midpoint. This is related to, right? So that's actually correct. Now where things become odd is that the L1 should just be the left side of the query A. Should be A. And R2 should be B, in theory. And R1 is going to be, I think, depending on how things go, that should be, it could be the smaller of mid. So L2 is going to be related to mid as well. Now, the query from A to B, B could be smaller than the midpoint or equal to the midpoint, in which case you take mid. If mid is smaller, it means B, which is what some other cases, right? B is the right of mid, then you would take the midpoint and break the query into two pieces, right? There in that way. Same thing on the other side, you're going to get the larger of the two, A, which could be to the right of the midpoint, or the midpoint should, in other cases, midpoints could be further to the right of A. Some cases, basically, the query is going to be, it's going to basically be self-contained. It's going to be broken into two pieces, but one piece is empty and one piece is self-contained. That's why you've got to have this min and max set properly with respect to mid. Otherwise, it's not going to fly. And what can happen is this midpoint could actually be, like, I guess what I'm trying to say is, how do I know when it's empty, right? Well, it could be empty when when B is smaller than the midpoint. So if B is smaller than the midpoint, right, then this midpoint L2 is actually going to be to the right of B, which is, it'll get skipped over here, which is why I have this going on. I think I have them doing that correctly. Yeah, it's a little bit Let's take some thinking to get that right. Definitely take some thinking to get that right. But this midpoint, it's important that this midpoint's not based off of A and B. It's based off of the current segment A and current segment B. No. This is like a very involved way of doing the segment tree. I don't think it's the best way to do it. I'm sure there's a better way, but this would perform the appropriate updates, I think. Query portions, yeah, each of these query portions. This also doesn't need initializer lists here. Oh boy. This is like quite a bit more involved than I thought it was going to be. This might just be slower than the straightforward quadratic time solution, just because it's a relatively small. Well, quadratic on 2000 is kind of a lot, but I think most of the time it's not going to be that much computation. Like this might actually just be a lot of extra machinery for this particular question, and it's ends up not being that much faster anyway. It might not be that much faster anyway. It might be asymptotically faster, but not much faster in terms of clock time, I guess, on these test cases. Might not be worth all this extra effort. I don't know. I guess we'll see. But anyway, so yeah, that actually will perform the updates as I need them, and then finally the result at the end is going to look like the following. So it's going to be a string, result, size n, characters A in there. For each integer, I is 0, I is less than n, increment I, const char ch is going to be also I think this goes, trying to remember how this works exactly. I think the constructor has position count. Oh, it's count and then character. Okay, yeah, I did that. Okay, I did that. Count and then character. Yeah. Just a bunch of A's. Just throw those A's in there. This is the original position by original string, something like that. Maybe it's better. Not original string, but just like new string, like, I don't know. Character sequence, maybe it's better. Try to think of a name before for that was reasonable. Okay, and then I'm going to say result. I'm going to say int x starts off at I, and then I'm going to loop through for I'm going to take my segment tree. I'm going to walk down my segment tree until I get to index I. Until I get to index I for how does that work? Well, I think I just check to see which interval contain. Yeah, I think I know what to do. So let's do a loop, a while loop. While x and say current index equals 0, while segment of current index of b, I is less than or equal to, and I is greater than or equal to, or and I is, yeah, a. All right. So while I is greater than or equal to a and less than or equal to b, I'm going to apply to m is 1 and b is 0. I'm going to update m to segment of current. Let's do const auto c segment, just current segment. Then say m is going to be the c segment m times m, or m times equals. Going to apply the whole composition straight through of all of these things. And then b is going to be b1, which is itself, times c segment m, plus b2, which is c segment y-int. Okay, a little confusing. Maybe I should just call this y-int. The y-intercept. And then I'm going to look at the left side and the right side. And update the current index depending on which side this is contained in. Excuse me. Okay. This is a little involved. It's a little bit much. So we bit shift to left 1, and we add 1 for sure. And then we say if I is not. Basically, if it's not in the left segment, then I'm going to increment. Go to the right. Current index plus 1 is less than n, and actually no, I don't need to check all that. I could just do C segment A, I is greater than or equal to C segment A, and I is less than or equal to mid. Okay, so I calculate the midpoint of this segment, and I check to see if I'm on the left side, meaning I'm between A and the midpoint, right? If I'm not on the left side, then I have to be on the right side. Yeah. or I could just be out of bounds altogether. Almost missed that. This will give me all of the modifications for m and y int. And then finally, I don't think I need this x at all, actually. Finally, I could take result, it's going to be set to ch, and that is going to be m times x plus y int. Actually perform the transformation on that index. This was like really complicated. This is really complicated. Okay. And by x, I mean I. This is just an I. Yeah. This should be linear arithmetic in time. Uses a segment tree. Kind of a complicated segment tree to put this together, though. I think this probably was not worth the time, actually. I mean, it wasn't terrible to get a little bit of extra time practicing these things. But it's definitely not terrible to practice this, but it's definitely pretty involved, and made a lot of excuses while I was doing this. And I was kind of kind of floundering a little bit there. Oh, right, A, B, and C, D. Yeah. So this is supposed to be A and B are A and B, and then C and D are current A and current B. C and D are current A and current B. It's a good catch by the compiler. Okay. I did mean that. Segment tree and current segment tree. I guess I can in place back with a struct. That's probably the issue. That's fine. Just add a default constructor, and int y int. It's just a b b m y int. I think I could do it that way. I don't recall if that's exactly how it's supposed to be done. I think I still hit a compiler for the other one. Oh boy. Okay. I'm really tired. I could feel it. Like ready to fall asleep. Ready to take a nap. Runtime. No. Dynamic stack buffer overflow. No kidding. No. Really? Oh. Oh no. This is. Oh no, I popped the queries. No, that should. Alrighty. How are we doing on time? 2 hours and 10 minutes. All right, let me try to see. Where exactly I get stuck. Okay. Deep breath. Yeah, I'm really tired. Really tired. Okay, doesn't get to 600. Also, freaking someone made a comment the other day, which I thought was very funny, which was it was like something you programmed when you were drunk, and I was like, people program when they're drunk? Are you kidding? That's completely insane. What? Excuse me? So apparently I got stuck somewhere here. Although I don't know. It's dynamic stack buffer overflow? I don't see that too often. Excuse me. Really? One, two, three, four. I can always reset these test cases, right? Yeah, 1, 2, 3, 4. I mean, this is just the setup, right? This is just the setup. Four times 4 is 16. Yeah, okay. What's the issue exactly? Excuse me. Oh, this is not. Oh, that's fine. I think this is supposed to be M, not N, over here. That was a mistake on my part. Same thing over here. These should also be M. I don't care about the ones that are larger. Maybe a little awkward using M and N because I'm actually using M for the other things too. Yeah, this one M. Say current M. That kind of matters. That kind of matters. Okay. I don't think we got that far, but it does matter. 400, 400, 400, 400. What is going on? Oops. Oh man. Oh boy. Okay. Okay. That gives me some information. 590, 400. So we don't get to 590. So something happens here, and I get an overflow error. I mean, I don't know what is. So I think it's too much memory. Is what it's telling me. Which kind of, I mean, that could happen, but it seems like it's only 16 elements, right? It shouldn't really be that much memory. Yeah, I don't. It's definitely not because it's too much memory. It's some kind of I think the index might be off. Oh, this is supposed to be M, not N. But even that, it should still reach. Still shouldn't be a problem if it's less than N. Of course it is. Oh, that's why. Oh, I didn't even notice this. This needs to be. I totally missed that. Okay. Oh my goodness. Oh my goodness. Of course. I didn't. I should have. Oops. Okay. That's correct. Nothing wrong. Didn't do nothing wrong. Didn't do nothing wrong. Ain't done nothing wrong. Okay. Let's go again. It's one heck of an algorithm over here. This is really a lot of work to. I mean, it probably doesn't have to be this much work. I would guess. Probably not. Just making it. Well, it is technically asymptotically more efficient if I do it this way. I believe. Also, I'm not sure if there's a way to make this without the extra characters. Just like basically make. I guess you have to fill it with something, right? If you're gonna have all this, should fill it with something anyway. Okay. More test cases. Yeah, that's a lot. That's a lot of time, and it's wrong. 2 hours, almost 20 minutes, and it's wrong. Oh man. It's always good. Oh no, it's close. I just need to swap these ones. Once, twice, huh? It's close. It was darn close. Darn close. How about the other one? Really close. This one just needed to be reversed again. Okay. Also very close. Very close indeed. Very close. I don't know what to say here though. Okay. Hmm. Okay. Yeah, this is right. This part's right. Just thinking, like, how did I miss? I missed something somewhere here. How did I miss that? Maybe I missed a query. Let me make sure I got all the queries. Okay. Oh boy. Oh no. Okay. Whoa. Well, that's not correct. That would explain some things. I think it's supposed to be 2 and 3, right? 0, 1, 2, 3, 4, 5. It's supposed to be 0 to 5, and then 1, 2, 3, 4. 1, 4, and 0 to 5. So I get, yeah, okay, it's something wrong with how I'm doing this, running this stack over here. Oh, excuse me. I think I'm getting closer though. Uh, what is this? I can get rid of these. I believe I can get rid of those. Previous 1, 0. What? Oh, okay. You know what? I don't think I could tie it. I don't think I can destructure it this way. That might have something to do with it. Yeah, that might be why. I forgot about that. That's if you use a tie, it gets kind of awkward if you do it this way. Because these actually become references, I think, to these values. I think that's what's going on here. I just set these normally. Also, these are not a pair, right? Queries are pairs. Yeah. If I did it this way, I think I wouldn't have the same problem. I've almost made that mistake before. I think I caught myself the last time I was going to do that, but I did that this time, just not thinking it all the way through. I think that's a problem. Yes, that was a problem. That was definitely a problem. This is still wrong, but at least it's not quite as bad as before. I think that's the problem. Wait, what? It's different now. What is going on? Just giving me random numbers. What is happening? What? 2-0. Where did you get 2-0 from? What do you mean 2-0? No. Oh. Okay. Did I get 0-0 before? What is happening? Alright, maybe there's something wrong with the algorithm. Oh, it doesn't actually matter how I perform the queries, the order I perform the queries in, but they just need to be the right queries. They need to be the correct queries. Oh, that's why. Oh, that's my mistake. No, I did that wrong. Oops. I totally did that wrong. That's why it's giving me random things, is because it's oops. Never mind. Oh no, it is right. Okay, no, it's fine. 140. Okay, never mind. Take back what I said before about tying and whatnot. It's fine. I still think there's some weird reference type thing going on here, but it's a little bit unusual. But this is giving me okay, that's totally I don't know. I think I'm just getting tired. I think I'm just getting tired. Not paying attention when we're putting my debug statements. Just throwing it in there. All right, this is working as it should. Should be 1.4 and 0.5. That's right. Okay. Then the question is, if that's working correctly, then that means excuse me, there's something else going on here. Okay. 1405. What are these functions? F of 1 of x is going to be negative x plus 5, and f of 2 of x is going to be negative x plus 140 plus 5, negative x plus 5. And so everything from 0, 1, 2, 3, 4, and 5, all of those get negative x plus 5 applied to them. And then from 1 to 4, it's a composition of negative x plus 5 composed with negative f of 1 sub x plus 5, which gives me x plus -5 plus 5 is just x. So what are these compositions that I get for, let's just do some debug at the bottom here. Okay. Getting tired over here. Getting really ready to take a break. Really, probably ready to take a nap, quite frankly. All right, so I think the second query didn't really get applied. I just get 0, I get -1 and 5 for all of them. That's not quite right. Okay. Interesting. Oh, M is probably what this should be, not N. M. Not that it mattered. Okay. This is mid plus 1, not mid. That's a mistake on my part. I think I made the same mistake on another part too. Okay. No, did it right over here. No. Oh, what? Okay. Did I get 2 updates from this? Pretty sure, yeah, I printed those already. I definitely did 1.4 and 0.5. Excuse me. Did this happen more than once? I'm wondering if this even, I'm pretty sure Well, I guess we'll find out which part of the code is wrong. There could be a lot of different things that are wrong here. So this only happened once. So yeah, the other, 1 to 4 just didn't go anywhere. Okay. Excuse me. Definitely should have gone somewhere. So what's A and B? A and B in this case is the segment, which is 0, 5. And the query is 1, 4. So that's A, B. This is current A, current B. No, other way around. No. Current A, current B is the segment. Yeah, there's the query portion in the segment. Segment. The segment is from current A, current B. That's 0 to 5. The other part, 1 to 4, is AB. So I was saying, in order for them to have some kind of overlap, I've got to have A is less than or equal to CB, and B is greater than or equal to CA. Yes, A is less than or equal to CB, and B is greater than or equal to CA. Okay. Okay. So 1, 4 should have passed through here. Midpoint between 0 and 5. This shouldn't be 0 to 5. It should be, that might be part of the problem. This should be, no, it's n minus 1. No, that's so confusing. That's right. This is, what did we make this 4 times? I think that might be wrong, actually. That could be wrong. It could, well, I don't know if that matters. That probably doesn't matter. I'm wondering if I need to make this a power of 2. That's why everything's not working correctly. I don't know if that matters. I don't think it does. What if I just print the indices? I'm getting kind of tired. I think maybe I should take a break. Too many details here. Also, somewhat I'm starting to run out of ideas of what could be wrong. There's just a lot of detail going on. 0, 1, 3, 0, 1, 3. Their outputs. Okay. So yeah, it's need more paper. 0, 5, 1, 4. Maybe I should print some of this information, current A and current B. Okay. So 0, 1, 3 for both of these, I think. I'm not sure which one comes first. Actually, it shouldn't matter which one comes first. But problem is that only one of them is getting applied to some of these. 0, 23, 0, 11, 0, 5, and then it stops. 0, 23, 0, 11, 0, 5, and stops. Oh. No kidding. What is going on? Okay. Okay. Man. Okay, so in this case, we've got 0, 5, 0, 5. How am I doing on, okay. So this is fine, it should stop here, but why does it stop here? Shouldn't this keep going? I suppose this is fine. This should keep going. I don't know why it stops. What? Maybe I do need more indices to do this. Maybe it does need to go all the way. And I don't realize it. Oh man. Oh, I think that was the mistake. Yeah, I think it's supposed to go further, and I just don't realize it. No, don't tell me. Just go straight to 0, 0. Oh no. Oh no. Yeah. Okay. Of course. Okay. So this doesn't quite work the way I'd like it to, huh? Okay, much better. All right, now we're getting somewhere. A little bit better. So I think my mistake is that I should be using n. I should be using n here, after all. And I just. Oh no, it's still wrong. Still wrong. Uh-oh. Almost. What happened to my L value here, man? What happened there? What? It's close. Much closer. Much better. Okay. Way better. Way better. 0 through 5, and then I applied 2 through 4. I didn't apply 1 through 4 here for some reason. Yeah, that's definitely better. Let's remove some of these other things here. Okay. Now the question is, what else is wrong? Jeez, it's taking a while, huh? This is definitely taking a while. Very close though. It's close. Okay. Did I set 1? I suspect the 1-1 didn't get written too. Okay. All right. How are we doing? Four, 1, 4, 1, 2, 3, 4. Yeah, I saw this before, the 1, 1 and 0, 1. And I thought, okay, that should write a 1, 1, 1, 1 somewhere. But I didn't see it. Thought that was strange. See 3, 4, and 3, 5. 1, 2, 0, 2, 3, 4, 3, 5. One, 2, 0, 2, 1, 1, 0, 1. Oh, maybe. It's less than or equal to n? No, I shouldn't do it that way. What did I seeing here? Huh. A1, B1, current A is 0, current B is 1. These overlap. It's kind of confusing, I don't know. Okay. So left called, and we'll say right called. Okay. There's a lot of debugging, man. There's a lot of debugging. But that's fine. It's kind of expected. I think I mentioned this is like something I would really need to practice if I wanted to do this like quickly. So we don't even get to left called and right called here. I should get a right called here. That's why I'm wondering what's going on. Get here though. Huh. Yeah. So basically it fails this check. And I'm not sure why. Missing something here. I'm missing something important here. Sorry, where I see this 1101. Oh. Okay. That's quite a bit larger than n. 32? Should this be 3? How did that happen? Maybe 32. What do you mean it's 32? How did that happen? Why is he using so much memory? What? Huh. Oh. I think I understand the problem. This is kind of, this is, This needs to be n-1 at the top. Oh my goodness, what a headache. I think that's the issue. I think it's that simple. Okay. G. There we go. What a headache. What a headache, man. That's just... Okay. Right. Okay. Right. Of course. Yeah, this is... It's got a lot of details involved. Got a lot of pieces to it. A lot of things going on here. Very easy to make some mistakes. Oh, man. So much debugging. So much trying to figure out what I did wrong. Oh, okay. Still no. Oh. Just want to be done with this already. I've had enough, dude. This is such a headache. Say it ain't so. Say it ain't so. Say it ain't so. No. I may need to write a routine to make it perfect power of 2. I may need to write a routine to make this a power of 2. Keep things simple. I think that's the problem. It's just not getting what not getting what I'm supposed to get. 0, 1, 2, 3, 4, 5. Okay, so 4, 5 is what I'm having an issue with, and I could do this by hand to figure out what 4, 5 is supposed to be. It's the OC in the middle there. I'm spending so much time on this too. It's like really, it's a lot of time. This is a lot of time. It's true. It's true. So we get 0, 1, 2, 3, 4, 5, 6, 7. So 0, 7 is 1. We have 0, 1, 2, 3, 4, 5, 6, 0, 2, 3, 4, 5. So 2, 5 is another. And then 0, 1, 2, 3, 4, 5. 4, 5 is the third one. And I think that's all of them. 1, 2, 3. Yeah, looks like that. 1, 2, 3. Yes. So 0, 7, 2, 5, and 4, 5. All right. 0, 7 is, so f of 1 of x is going to be negative x plus 7. F of 2 of x is going to be negative x plus 7 again. And f of 3 of x is going to be negative x plus 9. Okay. So the one in the middle there is going to be, it's f of 3 of x, and then f of 2 applied to that, and then f of 1 applied to that. That gives me negative x plus 9, f of 2, f of 3, which is then f of 2 is negative x plus 9 times negative 1 plus 7, which then gives me f of 3 of x minus 9 plus 7, which is f of 3 of x minus 2, which is then negative x minus 2 plus 9. Yeah. I did that wrong. It's not negative x plus 9, it's negative x plus 7 is the f of 1. Then that's just x, which is just negative x plus 9. Okay. So these guys should be negative x plus 9, which is negative 1 times 9. But somehow I got negative 1 times 5 plus 5. 5, 5, 5, 5. Of course. Should be 9, not 5. Go ahead and check again the what's being placed, see what's being processed here. Need to use the bathroom. Like, not expecting this to take so much time. Really tired. Complaining a lot. Lots of complaining from me. Okay. It's all right. Just keep going. All right. So 4, 5. 2, 5. 0, 7. 4, 5, 2, 5, 0, 7. Yeah, that's right. Okay. What happened with 4, 5? What happened with 4, 5? This should have this should have affected 4 and 5 with 9, -1, 9. So I get 4, 5, and 4, 7. I get 4, 5, and 4, 5. Very good. And the 6, 7, 4, 5, and 6, 7 doesn't do anything. So 4, 5, and 4, 5 here, I get -1 and 9, right? And then 2, 5 should apply also to 4, 5. 2, 3, 0, 2. 4, 5, 4, 7. And eventually 4, 5, 4, 5. We get also -1, 7. And then 0, 7. Just go straight through to 0, 7. Oh wow. Cool. Which applies to everything, -1, 7. Okay. So over here, okay. Just want to see what's being calculated here. Okay. How are we doing here? Okay, debug message is incorrect. Not Ying. No, sir, not Ying. Not Ying. Not Ying. Okay, let's see some of these debug messages. Whoa, that's a lot. All right, 4 and 5 is what I'm interested in, right? So 4, -1, and 7. That's correct. The first application. There should be 3 applications, right? Then it's still 1, -7, and 7. 1, 0. What happened there? What? Not sure what's going on there. Then 1, -2. Why at -1, 5? Where did that come from? 4? That doesn't seem right. And then 1, 0 again. What is going on? Huh? What is happening? Okay, let's try again. Oh, deep breaths, deep breaths. Okay. All right. So I started with 0. No, this makes sense. This is actually fine. This is fine because you see, you skip some nodes. Some nodes you don't touch. No, that's actually right. I was confused, but actually some nodes should not. So this is working fine. The first node, index 0, should have -1.7. The next node, what comes first? This is actually supposed to look like this. Yeah, like this. This is how it's okay. So the second position didn't have anything touching it. The third position, though. Okay, now this is weird. Why did I end up with? Excuse me. What happened here? So the current m was -1, and y was 7, and then I multiplied by the didn't change the slope at all, but somehow I modified the y-int position to 5 here. Right? Oh no, this is after the is it before or after? That's after. Okay, so this ends up a negative. Yeah. Okay, this has a -2 in there. All right. Index 5 is 1, -2. Okay, that must be because I apply a -1.7 and a -1.9 to both of those spots. Okay, does that make sense? Oh, that's interesting. It may be the idea that I have is not quite right. How I'm setting up the composition of functions. It's a good question. Yeah, so that's definitely what's happening there. You get -1.7 and -1.9. End up with 1.2, 1 -2. Yes. Okay. That's what happened there. And then I applied a I just had -1.5 all the way through after that. Let's see. No. So -1.9, -1.7, -1.7. I applied -1.7 and -1.9 in one spot, and then I came in with -1.7. How come I didn't end up with -1.7 and 1 -2? I should have ended up with 1. Oh no, I should have ended up with -1.9. I end up with this. negative 1, 5. What? What? Oh no. F of 1 of x is negative. I think I might be doing it backwards. Might be the issue. Maybe I should be doing it the other direction. The compositions, that could be the problem. Yes, that's what's wrong. Oh no. This is yeah, -2. Oh, +1. Oh, okay. Negative x plus 7 minus 2 gives me negative x plus 5. Oh. If I do it the other way around though, f of 1 of f of 2 of x. Yeah, that could be the issue, is the composition order. F of 2 is, what do we say? F of 1 is negative x plus 7. So f of 2 is x minus 2. That gives me negative x minus 2 plus 7. Gives me negative x plus 2 plus 7 is negative x plus 9. Yes. It does matter the order of the compositions. It's a little awkward, huh? Uh-oh. Yeah, I think that means I need to do like a stack of, okay, that's fine. Stack, pairs, or just indices, stack of indices. Just indices push current index. Another while loop. Oh, okay. We'll just say index. I don't know what to call this. I, J, something, I don't know, alpha. I'm not sure what to call it. The rest of this is here. Excuse me. I think I need to still get this. I don't think I need to calculate these though. Yeah, I think that's fine. Let me comment this out. Oh, that's some lag. I'm getting tired. I might want this over here though. I'll keep it commented out for now. I don't know if I need it the whole time. I'll have to modify that too, something slightly different. Okay, let's try this. So yeah, the composition of functions is not commutative, and I kind of just assumed it was commutative. Yeah, there we go. Okay. Oh, so many mistakes. So many mistakes, so much to think about, so much to program. It's a lot. Very tired. Okay. Wow. Jeez. I want to not print those. So I like this solution. I think it's a clever idea. It's just really took a long time to program. The way that I programmed it, there's probably a way to do it that's a lot cleaner, I'm sure. A lot faster. And I think I also want. I want to produce more test cases, but I'm afraid to. I'm afraid to. The reason why I'm afraid to produce them, write the script, is because I have to I basically have to balance the strings, and it's going to be kind of a pain in the neck to automatically balance what I want to print. All right. All right. Let's try something like this. Let's go for something like this. Okay. That's pretty good. That's pretty good. I just go for it. I'm afraid to go for it. Like, there's a very high chance of something wrong, you know? Did I get all the debug? I kind of want to go for it, though, because, I don't know, testing it's going to be a pain in the neck to go through all the test cases. To try to generate test cases. Generating them by hand is going to be awkward, and even generating them with a script is going to be awkward, so just try it. Oh, look at that. Hey, 100%. Beautiful. I like that. there's a beautiful, worth it. Just beats everybody. Just so fast. So fast. That's what I like to see. Also got my +1 coin. +1 daily check-in. Very good. Very good. Very nice. Very nice. You know, sometimes I tell people about future technologies that are coming, and they just don't believe me. Like, they just outright are like, I don't believe you. I don't think it's gonna happen like that. I just think it's not possible. And I'm like, no, I'm pretty sure it's possible. It's like, no, it's not possible. Like, okay. And I don't know. Sometimes when I do well, I'm just kind of like, I'm probably right. I'm probably right. I think I'm like, no, I don't know. I can see things other people can't see. It's just the truth. Not the best, not always the best all the time, but sometimes I'm better. Sometimes I'm just better. When I am, I don't know. Feels good. Feels good, and I'm grateful. So there you go. That's a linear rhythmic solution using a segment tree. Quite a long time it took to program that. Also cool. I got the 0 milliseconds 100% solution, which is great. Although it looks like most of the solutions are 0 milliseconds, so I probably should have gone with the quadratic time solution that's probably 100% also for probably 0 milliseconds too. But linear arithmetic's pretty good. This is n log n time. This is not a quadratic time solution. So it's much more efficient on larger test cases. Unfortunately, this wasn't a very large test case. So I'm trying to get 0 milliseconds again so I get a nice screenshot. But got there. Wow, cool that it, like, the first one I submitted got 0 milliseconds, then everything after that was slower. 1, 2, 3, 4, 5. Kind of unfortunate, but yeah, that feels good. I need to use the bathroom. I need to go to sleep. I like take a nap. I was like complaining the whole time. Complaining the whole time. It's like I guess I was the one that chose it to come up with a, much more challenging solution. But yeah, I mean, linear arithmetic is good, man. I mean, that was clever. That was cool idea, cool thing. Little tricky, kind of involved, but not bad. Not bad. Linear extra memory, I think. Very close to getting the 0 milliseconds. Okay, yeah. So it looks like most people got 0 milliseconds anyway. So all right, not too not too impressive. This is it's not really that fast either, given the constraints and the test cases and all that. It's actually kind of on the slower side, but it's also only 2,000 elements. If it was like 100,000 elements, I think the other solutions would just outright timeout, whereas this would be pretty quick. This wouldn't change very much in terms of speed. 1, 2, 3, 4, 5, 6. Well, it would change, but it wouldn't change as dramatically as the other algorithms could or would. So there you go. Can I get a 100%? There it is. Boom. There's a screen cap, I guess. I don't know if I should. Well, I have my full name on the. Yeah, it uses a lot of memory though. Yeah, I guess you don't have to use that much memory for this. Look at. It's like a handful of solutions that aren't 100%. Okay. That's fine. All right. Got there. Yeah, I don't know if I should spend that much time. That seems like maybe too much time. It can be done using a segment tree, as I explained, and that is efficient. So there's the, not just in theory, but in practice. Actually coded it. Took a while though. Not ideal, not great. I don't know how maybe there's a way you could program that faster. Probably, like some other people probably could do it very quick. But for me, I would need to practice. Like I would just need to think about it more and practice more. Like just be kind of ready to program that if I wanted to do it that quickly and with that time complexity. Oh yeah, it's just anything with a segment tree is going to take me longer than like a few minutes. I mean, I could, if I do more questions with segment trees, I could get it down to where I could use the breadth first search rather than the recursion, and then yeah, just be like a little more comfortable with all the different mechanics involved, different pieces. But anyway, okay. Yeah, so yeah, thank you for watching. If you liked this video, give it a like and subscribe for more. I'm going to stop there. That was a bit of a doozy for me. That was a bit much for me. That was, yeah, it wasn't a particularly hard question. It was just a lot of time for me to put together the segment tree. I had to really think through a bunch of different details to make sure it was correct. And I made a lot of mistakes, and I had to think about it for a while. I had to think about those mistakes for a while. Yeah, and I'm very tired now. Just kind of lethargic at this point, a bit lethargic, but that's okay. That's okay. We did it. I did it. Not bad. Another question down. I still have like 50 some odd questions to do, and then I think I'll take a break, a longer extended break. But Yeah. All right. Okay. Thanks for watching. Have a good rest of your day. Take care. Take care.